Somewhere in the center of our galaxy, there is a region of space where gravity becomes so strong that even light cannot escape. It is completely invisible. It makes no light of its own. And yet it contains the mass of more than 4 million suns. This is a black hole. Tonight, we'll slowly explore what black holes really are, how they form, what happens near their mysterious edge, and why they may hold some of the deepest secrets of the universe. A black hole is one of the strangest objects in the universe. It is not a hole in the usual sense. It is a region of space where gravity has become incredibly powerful. So powerful that nothing can escape once it passes a certain boundary. Not dust. Not gas. Not even light itself. Because light cannot escape, the object appears completely dark. Which is why we call it a black hole. Most black holes begin their story as enormous stars. Stars live for millions or sometimes billions of years. During their lifetime, they produce energy through nuclear fusion. Inside the core of the star, hydrogen atoms combine to form helium. This reaction releases tremendous energy. That energy pushes outward. Gravity pulls inward. For most of a star's life, these forces remain balanced. Eventually the star runs out of fuel. Without fusion pushing outward, gravity begins to take over. The core collapses rapidly. For the most massive stars, this collapse becomes unstoppable. The matter is compressed into an incredibly small region. Gravity becomes stronger and stronger. Eventually, a black hole forms. Every black hole has a boundary known as the event horizon. This is often described as the point of no return. If an object crosses this boundary, escape becomes impossible. The escape velocity becomes greater than the speed of light. And because nothing can travel faster than light, nothing can come back out. Black holes do more than simply pull objects inward. They warp the very fabric of space and time. According to Einstein's theory of general relativity, massive objects bend space-time. Near a black hole, this bending becomes extreme. Time itself begins to slow down. If you were observing someone falling toward a black hole, their clock would appear to tick more and more slowly. To a distant observer, the falling person would seem to slow down near the event horizon. Eventually they would appear almost frozen in time. This strange effect is called gravitational time dilation. Although black holes themselves are invisible, the area around them can be incredibly bright. gas and dust falling toward a black hole begin to spin. They form a glowing structure called an accretion disk. As the material spirals inward, it heats to extraordinary temperatures, sometimes hotter than the surface of stars. Some black holes are far larger than those formed by collapsing stars. These are called supermassive black holes. They can contain millions or even billions of times the mass of the Sun. Almost every galaxy appears to contain one at its center. The Milky Way's central black hole is called Sagittarius, a star. In 2019, scientists captured the first image of a black hole. This was achieved by linking radio telescopes across the entire Earth. Together they formed a virtual telescope the size of our planet. The image revealed a glowing ring of light surrounding a dark center. The shadow of the black hole itself. In the 1970s, physicist Stephen Hawking proposed something surprising. Black holes may not last forever. Through a process now called Hawking radiation, black holes can slowly lose energy. Over extremely long periods of time, they may eventually evaporate. Imagine drifting slowly through space toward a black hole. At first, it might not look very different from any other region of the universe. But as you move closer, something unusual begins to happen to the light around you. The gravity of the black hole bends space itself. And because light travels through space, its path bends as well. Distant stars would appear distorted, their light stretched into curved arcs around the darkness. This effect is known as gravitational lensing. The black hole acts almost like a cosmic magnifying glass, bending and focusing light from objects behind it. Near the edge of the event horizon, the view would become even stranger. Light from every direction could wrap around the black hole, allowing you to see parts of the universe that would normally be behind you. Some black holes are surrounded by enormous clouds of gas and dust. As this material falls inward, it forms a rapidly spinning accretion disk. Friction within the disk heats the gas to extraordinary temperatures. The result is an object known as a quasar. Quasars are among the brightest things in the entire universe. Some release more energy than hundreds of billions of stars combined. Yet all of that light ultimately comes from matter slowly falling toward a black hole. These distant beacons can be seen across billions of light years, meaning the light we observe today began its journey when the universe was still young. Black holes also inspire some of the most intriguing ideas in theoretical physics. One possibility is something called a wormhole. A wormhole would act as a shortcut through space-time. Instead of traveling across vast distances, space itself would fold, connecting two distant points. Some equations in general relativity allow solutions that resemble these tunnels. However, scientists believe that real wormholes would probably be unstable. If they formed at all, they might collapse almost instantly. For now, wormholes remain an idea, a fascinating possibility that continues to inspire research and imagination. Black holes are often imagined as cosmic monsters, but in reality, they are quiet objects. They drift through galaxies. They shape the motion of stars. And they reveal the strange behavior of space and time. Perhaps one day they will help us understand the deepest laws of the universe. Until then, they remain one of the most fascinating mysteries in the cosmos. Good night.